this player is not human. It's a computer program I wrote called Mario. This program started out knowing absolutely nothing about Super Mario World or Super Nintendo's. In fact, it didn't even know that pressing right on the controller would make the player
Good
go towards
morning.
the end of the level. It learned all of these things through a process called neuroevolution. In this video, I want to teach you about how Mario learned to beat this level, Donut Plains 1, what his brain looks like, and how it's all based on actual biological evolution. So let's start out by actually looking at Mario's brain. Let's play it again, but this time we'll look at Mario's brain as it's making the decisions of what buttons to press. It's going to look a bit complicated at first, but don't worry, I'll help break it down for you. This structure of colored lines and blinking boxes is called a neural network. It's a simple mathematical model for how a brain works, but it can produce some very complicated behavior. With enough computational power, a neural network could come close to simulating a real human brain, but modern technology isn't there yet. On the left side you have the inputs. This is what Mario sees. It's a simplified view of the level. The white squares stand for blocks the player can stand on, and the black squares stand for moving objects like enemies or mushrooms. On the right side you have the outputs. These are the 8 buttons that Mario is able to press by using its neural
Yeah.
network. In between the inputs and the outputs,
Thanks.
all those
You guys
lines
sit
and
downstairs then.
boxes, those are the neural network. Each free-floating box is called a neuron,
Oh, okay.
and the lines connecting those
Have fun.
boxes are like the
Okay.
axons and dendrites in a human brain. At any given time, only some of these neurons and connections are actually being used, and this is what people talk about when they say you only use 10% of your brain. The neural network you're seeing is a pretty complicated one, and it got so complicated as a result of a 24-hour evolutionary learning session. So, to explain how neural networks work, let's rewind about 24 hours and look at how the whole process started. This is what Mario looked like at the beginning of its training session, all the way back in generation number 0. The program is probably even dumber than you thought at this point. Often it just stands there and doesn't even press any buttons. If Mario stands still for too long, it'll cut off the
Any of you see
simulation
this
and try the
before?
next neural network, so it's mostly just jumping from one simulation to the next. But occasionally, the neural network says to press the right button, and the player starts walking right. Behavior isn't complicated, but it's enough to make at least some progress in the level. Let's take a look at a sample neural network to understand just how that works.
Different than
This
the
is one of
usual.
the randomly generated neural networks that appeared in the first generation of the simulation.
Something wave.
There are some green
Whenever
lines
we
and a
play.
red line, and one neuron in the middle. Here's how it works. A green line is a positive connection, and a red line is a negative connection. A green line reading from a black or white square will turn its output the same color. A red line reading from a black or white square will turn its output the opposite color. In this case, the green lines read from the platform that the player is standing on and make the neural network press the right button as long as the player is standing on it. However, when the red line reads a black square representing one of those caped Koopas, it presses the A button and makes the player jump. This puts the player in a position where the green lines are no longer reading a white square, so the right button turns off and Mario just stands there. This is a really basic example that illustrates how a more complicated neural network might operate. The more lines and neurons you have, the more nuanced the decisions can be. So, how exactly do we get those more complicated neural networks? The answer is evolution. When Mario gets further right on the screen, its fitness goes up. In this case, fitness is a function of how far right it gets and how quickly it gets there. Only the neural networks that produce the highest fitness are selected to be bred, creating the next generation. It took 34 generations of genetic breeding and fitness evaluation before Mario was able to finish the level without dying and get a fitness score above 4,000. You can see there were several places it got stuck for a few generations, but it always evolved out of those ruts. Let's take a look at a few of those ruts. You can look at the top left corner of the screen to see what generation number each rut occurred on. This process of picking the fittest individuals from each generation, breeding them together, and adding random mutations very closely matches the actual process of biological evolution that took single-celled organisms and produced intelligent humans. That's the power of neuroevolution. And though we don't yet have enough computational resources to produce something on the level of a human brain this way, it's kind of neat to see what it can do on one of my favorite games. I didn't come up with this idea on my own. This algorithm is called NEAT, which stands for Neuroevolution of Augmenting Topologies, and it's based on a paper by Kenneth Stanley and Risto Mikulainen. It's a really great paper that describes how to use genetic algorithms to build up neural networks from bare bones without presupposing the best structure for the neurons and their connections. It also includes some really cool ideas for separating
Hey,
genomes
it's 9
into
o'clock.
species, which a lot of genetic algorithms don't really becomes prominent. That's about it. Thanks for watching.
Anyway, I find that stuff fascinating. I've done a little bit of playing around with that kind of a thing, and the ideas make sense, and it's pretty neat what you can do with that. The neat stuff, I've done a lot of little genetic algorithms work in the past, but the headache of reading a video game screen and doing image processing on each and every one of those frames is just painful. Anyway, I think that stuff's cool, so there you all go, if you get that. All right, 9 o'clock. Hope everybody had a good weekend. Looks like we are getting voice output in here, so I think that's means everything's working. How is the homework assignment going for all of you? Got a new desk set up, so I haven't quite got my camera placed there. There we go. Great, totally started it. It's good that you started it early. I'm glad that you're. It's fine. So let me pull it up really quick. Come on, why do you always log me out right before class? Swear. All right, assignments. Two things. So homework assignments due, but I've had a couple questions from people in various classes. Let's bang on the door when Dad's in class. If you don't know where the recordings are, class sessions, VOD. So here's all the YouTube links to class. If you missed class, feel free to watch the video, ask me questions on what you missed. But again, they're all in the class sessions. I feel like I've said that a couple times already, but you know, if you missed it, that's fine. That's where it is. Okay, other thing. Your group assignment, individual homework assignment is due on the 19th, right? So that is this Friday. Make sure that you do start it because there is a team component to it where you have to come up with a project proposal and it should be written like a technical document. So make sure you get that taken care of. It's not, I don't think it's that much of a difficulty in terms of technical prowess here. You know, you're getting up and running with GitHub, which for some of you is probably a new thing. But you have to work together as a team for the first time, really. So make sure that that is happening. I did have one question on the extra credits too. So one of the things is if you want to, oh, I just realized I answered one of you incorrectly, so I'll fix that later on. Basically, you have a personal term project or a personal repository that you're creating for this assignment. This is going to become your personal portfolio page. If you already have one, feel free to get rid of this at the end of the semester. But it's good to have a web presence for you, you know, with all of your technical information that you can very easily point an employer to. So if you get it up and running, you can get a little bit of extra credit there. And if you make it really pretty, I'll give you up to the full 25 points, basically. So um, I think usually what I'll do for this is if you go through all the effort, you know, I'll give you a good chunk of them. And then if you make it look nice and pretty, you'll go above there. So, but keep that in mind. To remember to fix that email because I answered that wrong. All right, so that's about it for the homework. Again, due Friday. Make sure you get it done. Anyway, back to configuration management. So we left off last time and you know, I'm past the slide, obviously, if you remember. But the goal here was for consistency, right? And you're going to have lots of headaches and problems with configuration management, with keeping files out of merge conflicts or, you know, dealing with rolling back or creating releases and all that fun stuff. But again, we're going for consistency. Consistency in the project, consistency in your files, in your process. Basically, be consistent is kind of the key, excuse me, key takeaway here. You belong over here. Over here. All right, so this is it here? Where'd we end up? Ended here. Okay. No, we didn't end up here. No, we did end up here. Okay. Just trying to make sure my notes from last year where we ended don't conflict with this semester. But yeah, we were talking about baselines and we were talking about tagging, right? And as a refresher, configuration management tracks our files. It houses the technical side of our process. And tagging or baselining effectively gives you a software release or a project release with a set of files at a particular version number, where each of these files can be at a different version. They don't all have to be 1.2.5. Again, file A could be 0.1, file B could be 10.2, whatever. It's just this is the state of the project. Typically, this is an approved state, so everybody's happy with this release or this tag. Generally, you have a check mark to say this is good, this is bad, and that's going to be an internal thing to your project team. With this, though, this is going to play kind of nicely into configuration management. What you're doing in your term projects, this doesn't strictly make sense, right? It seems like a little bit overboard for, a project team of 2 to 4 people where you're just doing a term project, you're going to commit all your files, probably not worry about any of that stuff, right? Imagine you're in a team of like 100 people, 50 people, maybe all the stakeholders included, there's 200 people involved. Hopefully this kind of notion of scale helps you kind of, think about why these processes are necessary, why it's important to understand what all of the versions of these files are when you make a checkpoint or a tag or a baseline. Effectively, if you bring on an intern, say, right? So one of you goes to work for a big company over the summer, and they give you a project to update a GUI on a mobile app, right? That's kind of a nice, easy project for somebody fresh to the working world, make some updates. Well, you go down and pull the repository onto your machine, and you have no idea the state of things. You just know, okay, I'm pulling down release candidate 5. That brings in every single file that is tied to that candidate that's tagged, right? But if you didn't have that identifier, you wouldn't know what to pull down. You might just pull down the head of the project and you have all the development stuff. Maybe it doesn't work. And then how do you, find out what you need? That's kind of basically the purpose of tagging and baselining, really. So it's a common, nice way to talk about things. Hopefully that makes sense. Again, for fun projects, probably won't use tagging or baselining too much. If you go out and you start making software, like if you start contributing to GitHub, maybe you have a really cool project that you put up there and people are actually using it, you might have a release version. And if you're doing it in GitHub, it's going to be a tag. But release candidate 1 is this tag, release candidate 2, and then you can basically have your list of releases with all the different commits on there. So just, hopefully not talking in circles too much. Okay, so that's tagging and baselining, mostly for internal purposes. One of the next things we have to deal with is actually release configuration. And what a release does is it gives you a packaged up application ready to be deployed to some stakeholder. Could be internal for review, could be external for your customers and your clients. It basically just kind of depends on what the release is intended for, right? Is it an internal build? Is it an alpha build? Is it a beta? Is it the final? That's going to be part of the process how we decide that. So to get a release candidate or a release, same process, tag or baseline your files. So freeze the version numbers. This is this particular release candidate. This tagged group of files goes into our system, right? So this is basically our baseline, our tag, our release candidate. I'm using the same words, it's basically the same thing. Checkpoint's another one. This group of files goes into your build process, your build chain. This will differ company to company. Some of you will go to use a CI/CD pipeline like Travis or Jenkins, where you send a tag to this framework up in the cloud. It does all your builds, it does all your automated testing. You get a report at the end. Or it's a little more manual. You put your tag in, and that kicks off a process of, okay, the testing group now has to work on this. Um, Maybe you have to bring in the quality assurance group. Maybe you do code reviews, whatever your particular software engineering process states. This is where it's going to happen. If everybody's happy, you get a release name. And that goes into a formal repository, which is part of your config management tool. So GitHub, you look at any open source projects that is being used by lots of people, you'll probably see a list of releases, right? Here is release 1, here's release 10. Um, Again, I really need to think these demos through better. I've been playing with Windows Terminal a little bit, and I know that is a open source project now. So I can see projects, sorry, code. Yeah, releases. I can never remember where they put stuff in here. So here's basically a tag for Windows Terminal 1.6.10412.0. I could pull down this tag basically, and it has all of the source code associated with this particular release number. Right, and you get a whole bunch of information about what this thing does, and it could be any project, right? It doesn't have to be terminal. But these are basically releases which are just tagged. The release means it's gone through the formal build chain. Effectively, all I'm really blowing this up to be more complicated than it is. Um, you're just labeling stuff in your repositories. That's all you're really doing. It's just some of these labels have more importance to them or they carry more weight. But does that all make sense, more or less? Hopefully. Terribly exciting, I'm sure. I'm sure half of you have something else going on in the background to ignore the boringness, but um, it's a very powerful tool for you. Once more. The question? Okay. Does release tagging, release management make sense? Ah, crap, I forgot to hit record. Well, you're gonna get the beginning of the Twitch stream in the VOD then. It's one of the other reasons I really like doing this on Twitch is that I can just pull down the video from Twitch when I'm done. Not like other classes where if you forget to hit record, it's gone forever, for the most part. Okay. Usually when I ask, does this make sense? Is it clear? I'll probably ask you again on an exam or a homework question or something like that. So some of this stuff is good to figure out. Okay, so we have development config management and we have release configuration management. And one question you may have, or that I will have for you, is the difference between development and release. And they're basically going to be the same process. I don't have a slide or anything like this for you. But the key here is that development is continuous, right? So we're always going to be developing on our project. We're always going to be updating our development chain, all of the files that are in development until we are ready to be done and, move on to the next project. But development's continuous. Release config management will use the same or very similar tools, but this is a formal process to basically produce some kind of a packaged up build. It will have test reports, it will have labels, it will have all the check marks to move you through your software engineering process. Basically, think of release configuration management as a checkpoint in time with all the rigor that goes behind making that checkpoint valid. Development's going to be continuous. We're going to keep working on things. Now, does that mean that development won't use testing, that it won't use a pipeline of some kind? No, absolutely, it can, absolutely. But we're going to keep iterating. Release, you're going to have a tag or a build number. You are done with that unless you have to go back and fix things, in which case you would make a new release. So we're basically trying to formally freeze things in time with release config. And for this question here, how do they work together? One feeds into the other, right? So if we were in the classroom, I'd sit there and stare at you blankly. Won't make you do that on stream today. But again, development and release configuration management, these are the same tools, right? So you're going to be using Git, you'll be using Subversion, you'll be using whatever your company has in place. It's just going to be different aspects of that tool, right? All the stuff you do in development is going to feed into the release configuration management. I'm going to be working on frontend.gd or .java or whatever the Kotlin extension is these days. Release configuration management, we're just going to go in, pick the files that we think are ready to be released, and then we're going to try to move ahead. All right, 2 more slides here, and then we can move on to a little bit of Git. So let's talk about an actual workflow, because I've kind of given this to you as a high level, okay, this is configuration management. Hopefully makes sense. I'm sure you've all used it by now if you've done the homework. If you haven't, you'll be doing more Git. Well, let's say that you have a project, okay? Term project, personal project, whatever you want. Would recommend if you are getting into doing little personal hobby projects, get comfortable using GitHub with it, because if your computer goes to crap and it's unrecoverable or irrecoverable, you can just pull it down from GitHub when you fix it. Not that that's ever happened to me, or speaking from experience there. But it's kind of a good habit to get into, even if it's a little bit of extra effort. Anyway, you have a project. That project's going to have milestones. What is a milestone? We need to show progress at some point. The GUI is done. My socket to talk to the backend is complete. I am pulling user database information and displaying it on screen. Right? I have milestones to get through. Maybe we are at the milestone of validation where we have to do testing. We're at the milestone of requirements engineering, where our requirements are entered into the system. We've put them into a config management tool. We can move on to development now. All right, so these milestones are basically just kind of key things to move you on through that software engineering lifecycle that we talked about the past few classes. Again, it doesn't matter if it's waterfall or agile or any in between, you're going to have milestones to hit. To make that succeed in your config management tool, you're going to create tasks. You will create issues. You will create stories. It just depends on the tool, what they call it. But you will be entered into the system as a user object. Bormeko, I'll probably pronounce your username incorrectly there. You would be a developer in the system, right? You are entered in as a user object. I'm going to create a list of tasks for you in the system. I will assign them all to you. As you develop your project, you will check in code associated with that task. When we run the report at the end of the project, we see all these tasks have been completed. And if we discover there's like all kinds of testing problems with the GUI, we can see, okay, what's been done with that task. Okay, here's all the check-ins, here's all the commits. This is the problem, right? And then we can say, hey, you go ahead and fix it, because you're the one that put all the code in. But that's going to help us move along, right? This is the log of our project development. We can see over time what happens, and that information is going to be necessary as you go for auditing purposes to demonstrate forward motion in your project. Basically, it's necessary. It sounds awful, but it's necessary. So what is our pipeline here? Create a project. So you create a new repository in GitHub, you create a new project in tool, whatever you're using. Based on where you're at, create a bunch of tasks. Task 1, write requirements. Task 2, discuss requirements with customer. Task 3, develop project. Task 3.1, add GUI. Task 3.2, add database, right? All of these nitty-gritty things that you can really move your project along. And then assign people those tasks, get them all done, project's done, right? So if we create a bunch of tasks, assign them to all of you, we've got approximately 30 people in class. If I created 30 tasks, assigned one to each and every single one of you, you all did your work and closed your tasks, closed your tickets, closed your stories, whatever that's called. Are we done? So I look in my config management tool as the project manager, and I see everybody has checked off their tasks. Maybe you even put it through the testing pipeline, and we've gotten feedback that everything's good. We create a release candidate. Are we done? All right, question popped to you over in chat. No, because of revision. Thank you. Depending on the project, you may never be done. um, you have revisions, right? So maybe something went wrong. Maybe you have to make updates and you go through the process again. But basically, let's say that we are at a release state, the customer's happy, we've given them a released version. We now have to enter the maintenance phase, right? That's where we deal with things that crop up after delivery. And how long that maintenance phase goes on for depends on your contract with the customer. It depends on your good faith with your user base, I suppose. Um, Basically, you have to keep supporting your software for as long as you say you did. Right? I'm going to support this for 5 years and then I'm never touching it again. We'll release it as abandonware or something like that. But not strictly true, basically. We're not done. We have all of our paperwork, all of our auditing to do, all that fun stuff. So your answer about revision is basically pretty close there, yeah. Alrighty, last slide here. We also have a notion of change management. And this is where the administrative auditing type stuff comes into play. So we have development configuration management, we have release configuration management. Those two are tied together. Change management is different. Now, it may be baked into your tool that you're using, but what this is doing is it is giving you another process, which we all love to hear. All the processes, please. How do you make changes to your source code? And that's an interesting question. And it's going to sound horribly non-interesting to you as students, because I can guarantee we don't want to care about this stuff at this phase, right? And I'm not saying that like condescendingly, just this sounds awful to deal with. But let's say that you put together a software release and a problem is discovered with it. And you'd say, okay, well, I'll just go back in and I'll fix it, right? I'll make a tweak, I'll fix my parameter, whatever the problem was that caused 20 users to have issues. It's not always that easy. You can't just go back in and change things in a formal project that is under some kind of a software engineering process, right? I keep making a big deal about you have very specific ways to move from activity to activity in your software engineering lifecycle in that software process chain because there are so many people that are impacted, right? So it's not just you, the developer, it's the testers, it's your project managers, it's the entire company supporting the project has to deal with the change here. So basically what happens, just to, enough introduction here, let's say a change has to be made somewhere in the project. You might have a workflow that looks kind of like this flow chart here where a problem is discovered and then you have to categorize it. Is it a major issue? Is it an emergency? Is it a quality of life change? Right? What is this change going to mean to the project? Because again, think of it. If you've done a release then let's say it went to the users, you have to go through that entire process over again to have this change. And you might streamline that change, right, based on your software engineering process. But maybe you have to go through testing, quality assurance, user testing, all of your internal checkpoints. This all has to be redone based on how broad this change is. Maybe you need to bring in an emergency committee of people in your group to figure out what has to be done. Um, maybe there's going to be a user that goes through and approves all these changes that you're making. Um, if it is a small, silly little thing, like maybe you're moving a text box or changing a font or something like that, yeah, it doesn't have to be a disastrous, world-changing thing. But if you're like switching from MySQL to a Firebase type of thing, or something nifty like that, it's probably going to have far-reaching implications, and it has to actually be rigorously approved. So basically, this is a layer above the layer above the development side of things. So we have our project development, all of your artifacts, right? The requirements, software testing, all that basic stuff. That goes into your configuration management tool so that we can track things. Change management is a layer above that where, yes, you are allowed to make this change. No, you are not allowed to make this change. Do not touch this file, right? So how do we actually make changes? And we don't have to go into this in great detail, but basically, I'm trying to sell it to be very, very important. It's basically you as the user have access, right? Or sorry, you as the developer have access to update this file, attach it to the task that you are assigned. It is approved by your change manager. We close it, we move on. Right? So we're basically just putting in an extra layer of oversight here. Okay, enough about part one of configuration management. Any questions lingering from this aspect? And if we are all good, we can move on to part two. So one of you in the Discord chat got me using the new Windows terminal, which so far I like. I like that it's a little bit more stylable than pure Windows or WSL. Some things are kind of annoying, but overall it's pretty neat. Next thing I need to do with it is style it a little bit. Give it a nice retro aesthetic without that. Seems everybody uses that power line theme for your terminal, and that's not my jam, I suppose. All right, if we are all good, we can move right along. Now we're going to talk about the different types of config management tools, and really it breaks down to Git and not Git. All right. So I have you all using Git and GitHub this semester, right? And what that means is that you are gaining exposure to a tool that a very large chunk of developers worldwide are using right now. For the longest time, we did not really use Git. Companies were kind of leery of it. It's an open source tool. Why would you use something open source when you can pay a lot of money in licensing fees? But that's beside the point. It is a new paradigm, to use a word that's probably quite played out in the field of computer science, but effectively, it's good to get experience with. Anybody know who created Git? That is actively paying attention. He said feeling tired, I guess? Cheeky? I don't know. Who created Git? Someone named Git. Haha, got him. A real Git. There you go. Benefit of having class online, you just have Google there without somebody glaring at you from the front of the room. Yep, Linus Torvalds. Linus Torvalds, the god of computers. There you go. Yeah. Every time I see one of those Linus tech tip videos pop up, I have the momentary worry that he dropped developing Linux and started doing product reviews. Yeah, so the guy who created Linux also created Git. Linus does everything he does, right? So Git was developed as a way to manage and distribute Linux effectively, which I find kind of interesting as somebody who really likes working in the Linux environment, even though I'm clearly on Windows here. But basically, standard configuration management tools were not working because of this massive open source project he kicked off, where you have people contributing worldwide in real time, and it basically became quite painful to deal with standard source control. And since 2005, it has, this statistic here is out of date slightly. As of a couple years ago, about 43% of all developers were using it as their primary source control. And I know that a lot of teams have since moved on from something internal or licensed or to Git. And the other one's going to be in like the Atlassian or Perforce type of environments too. But it's open source, it's free, it's actually pretty easy to set up. If you want to run a Git server on a local leftover computer that you have somewhere, it's super easy to get up and running. You don't need the nice, pretty GitHub style interface to run a Git server. But it is pretty common and it's good for you all to get experience with it. The interesting thing, though, is that it's currently owned by Microsoft. I'm not sure if anybody's aware of that. I think this is kind of a ironic twist of fate. GitHub is owned by Microsoft. Git is open source. Um, GitHub started out quite a while ago as a way to host Git servers, and it's changed over time. So the licensing scheme with GitHub originally was you only had a certain number of repositories you could set up. You basically didn't have all the free resources. Yeah, Google does own everything. Interestingly, there's a bunch of Google GitHub repos out there that are pretty neat too. They've done a lot of open sourcing of their internal stuff. Microsoft's kind of migrated to open sourcing a lot of their stuff as well. But for about a year, and this was just a few years back now, there was a massive concern that GitHub was going under. Okay. So think of all the open source projects that we have right now that you can go to GitHub and pull down. That might not be here. Microsoft bailed out GitHub. I'm sure there's obviously business reasons why you do that, but I want to say it was like 2015, 2016, something like that. Maybe even later, 2017. Microsoft bought GitHub. It was a massive concern. Okay, Microsoft now owns all this open source code, and they start contributing their own stuff to it, which is pretty cool. And we still have it. So basically, with all this GitHub stuff that we are doing, be happy that Microsoft bought it because that means we have unlimited free repositories right now. I think you were limited to like one public and a, several private a while back. Otherwise, you'd have to run your own server, and it was kind of annoying. But it's a good thing to get experience with. And again, GitHub is just the shiny front end, right? We also have GitLab out there. I've mentioned that once or twice. This is where you can, I think you can actually host it with them too. You can run your own GitLab server, and it's basically just a shiny open source interface of GitHub. I don't want to register for that. And then somebody actually, let me pull up in the Discord chat here from the CIS server. This was a new thing that I noticed. Is it programming? Up. Sorry, I didn't mean to completely break up class here. Ah, crap, where is that? Of course, I'm not going to be able to find it right now. There is a new interface to GitHub. I'm just in the wrong thing here. 1S, that's right. So if we go to GitHub, was it 1S? Ah, I've been to one of these pages before. I guess I can't find it now. Um, basically somebody put Git bucket. Oh, that's interesting. I can't say I've ever used that. Yeah, Bitbucket's one of the other ones. Git bucket is I'll have to look into that. But there's this GitHub 1S thing now where basically you have a VS Code interface to a GitHub project, which I think is kind of fascinating that this is an option now too. But like here's I mean it looks like VS Code, right? So I think you just add a 1S and let's see if so I'm just playing with this now. I'm not necessarily and you're all thinking, no, this is great content for class. If I go to my README file, can I do this? Probably not. Maybe. Ooh, I can. Nope. Okay. Oh, sorry, it was big. Okay, I thought there was a new thing. Yeah. Because you can use Git to check out Bitbucket stuff. Okay, so I have to put it under revision. Okay. Anyway, VS Code in the in a browser seems kind of neat. Yeah, there's Bitbucket too. I should probably show you this, or it's .org. A lot of oh, it's Atlassian. Okay, I forgot they bought them. Bitbucket's the Atlassian version of configuration management. You can use Git to check out from it though. Anyway, back to Git and other stuff. So with you've hopefully all gotten a little bit of experience with Git so far, right? You did that little JavaScript demo thing which hides a lot of the commands under the hood, but you kind of get an idea of what it looks like kind of visually. The interesting thing with Git is that it is a distributed system, and we'll talk about that in a moment. But your typical process for Git is that you do git add, git commit, git push, and then, you know, if you're not familiar with configuration management, you know that you've taken what's on your computer and put it to the server, right? So basically we have this notion of basically 4 different databases with Git. And this is getting into the infrastructure side of things, the under the hood kind of things that the IT professionals would normally do. But your local project folder has a database inside of it. Right, so if we look at, so I'm in my Git repo for my class project here. So if I do ls-la, A is going to show you all the hidden files. We see this Git folder, this .git folder. If we look inside that, we see a whole bunch of gobbledygook that actually looks kind of important. This is basically configuring your local Git database. It has your branches, has objects, references, what your head is pointing at. Don't go in here and modify things unless you really know what you're doing, because it's very easy to break a Git project. But if we say cat git head, we can see where we're pointing at. And again, this is all under the hood stuff being taken care of by Git, but you have a local database. So this is your local workspace. We're going to have an index that we're going to add to. We'll have a local repository that we commit to, and then a remote repository which we push to. And so this will hopefully all become clear in a moment. But this is basically your local working environment. This is your staging area where I have added stuff to be tracked. I have added stuff that has changed. And once we do the add command, it is basically staged for commits. And what that means is that you have files ready to go. They're being packaged up. And once you do that commit, then we write the changes to our local repository. This will hopefully become clear as we go. Basically, you're kind of boiling up from local to remote. And again, remote is where everybody else can see stuff. If you're in one of these first 3 stages of the Git process, only you see it. The only time that your teammates can see it is once you do that push, because that sends it to the remote server. On the other side of things, We can do a git pull. We can do a rebase, but hopefully we don't have to. Rebase usually means there's some kind of a merge conflict. We can do a fetch. We can do a checkout. We can do a diff. Basically, these stages are bringing files into your local working environment. All right, so if you're doing a git pull, basically you're taking what's on the remote and you're bringing it into your local workspace to work on. So when I tell each and every one of you to do a git pull before you start work for the day, or before, you're sitting down to work, you're making sure that any changes that a teammate has put up are on your local machine. And the thing with pull and fetch, you might see git pull or git fetch if you look up commands. They're both downloading files, except git pull is updating everything. So it should be like resetting all of your pointers to the various files. Basically, you're bringing in the remote state and making it your own. Git fetch just downloads files, so it doesn't really go through and update your other databases. And checkout, you can basically pull down particular versions of files. Diff is going to show you the differences between files, between the status of your repositories. We'll get into all of this stuff, don't worry. Okay, looks like we're going to end up in one or two slides here. So let's talk about Git. What we have in Git is that you have a set of objects that are committed, and then a set of references. And this is stuff that is going to help you understand what to do if you get into a merge conflict. Basically, you have to basically understand what head means, what a commit object means, and all that fun stuff. When you do a git commit, you're basically making a commit object. It's going to have an ID. It's that big long hex string. And then based on how your project is configured, your head or your branch version or whatever we're going to be using here is going to point at these commit objects, right? So that's basically all we have going on under the hood here for how the files are stored. Now, everything inside that repository is in that .git folder. And again, if I pop back over here, I do an ls, you don't see it. This is all the stuff that you see on the website front end for GitHub. But if I do ls-a, again, to show the hidden files, this is my local repository. It is all stored in a file-based format. There is not a database running on my machine. It's all file-based. Excuse me. So if I blow away this .git folder, I've deleted my local repository. I would need to reclone it because this is what is telling Git how to basically do its job, right? So one other thing with Git is that it is distributed. And this is kind of the notion that I want you all to really understand here. I've been talking about Git and Subversion. I've been kind of alluding to Subversion without showing it to you. Subversion is one of the standards. There are many other very similar types of environments. But with your standard configuration management tool, you have a central server somewhere. Okay. So if you go to work, let's say you go to work for GE or any of the local companies, and you are using something like Subversion, there will be a server sitting somewhere with your configuration management tool on it. And to do your job, you go out and you talk to that server, you pull down the files you're going to work on, and you go through that locking and checking in and checking out process that we talked about a while ago. A while ago being 2 days ago. Right now, today's Monday, right? Friday. So this whole working from home thing, I have no idea what day it is anymore. But the key is that it is on a server, okay? Standard config management tools are centralized. So there is a central server, probably with backups and all that fun stuff. But if I want to do any work, I have to talk to that server. Everything happens on the server. Okay, if we want to create branches, if I want to log things, if I want to do merges, if I want to do anything config management wise, it will be on that server somewhere. You have to remotely connect, you need an internet connection, that kind of fun stuff. Now you pull down a working copy to your computer, right? So you do a checkout I work on my files, and then I check them back in, do all the stuff I need to. Okay, again, server-based. Git is decentralized. There is no central server. Okay, so the key difference here is that you might have a remote repository, right? So for instance, in class, GitHub is our remote, but everything that we're going to be doing is going to be on your computers. And this is kind of an interesting thing to talk about mentally, where all of this administrative, um, formal process type of activity that's, typically housed on a central server, you're doing that all locally, right? So you're now have a working copy, which if we go back here, that's your workspace, okay? You're going to have a local repository, which is right here. Again, this line is all on your machine. And what makes this interesting is that everybody working on this project does the same thing. They all have a local Git server running effectively. You make all your changes here, and then you push it up to the remote. Basically, you push the entire thing as you go. And the entire thing being the changes that you made, right? If there are no changes to um, like a release, or there's no changes to tags, that doesn't need to be updated. All the changes are updated. But the only reason to have a remote repository is so people can work together. There's nothing magical happening up here. It's just the connection that everybody can pull from. And you might ask yourself, okay, well, don't we have the same problems? Okay, so poor analogy. Subversion would be like Google Docs and Git would be like Microsoft Word. Um, yes and no. So I actually do like that analogy because you need to be remotely connected if you're in Google Docs. Um, I'm not up and up on what Office 365 is doing behind the scenes, but yeah, so if Word basically means you can make your changes locally and push it up when you're done to the cloud, then yeah. Excuse me. But kind of where this really shines is when you have a big project team. So if I have a setup like Subversion here, okay, let's take the example that we are all working on the same project as a class, so 30 plus me, so 31 people. Maybe use OneDrive instead of Word. Yeah, something like that. Yeah, yeah, that would probably work. So you make all your, yeah, it's kind of iffy because it's reflecting your changes up to the server though, right? Um, shoot, what would this, I guess basically you have a distributed system. So everybody's working on the same repository and they just push their changes up to a remote server somewhere. So yeah, I guess your example of OneDrive, probably like a Dropbox would work type of a thing. There are some cute little differences, so I don't want to like commit to saying that's a perfect analogy, but you kind of have the idea. Yeah. Anyway, let me leave you with this. So we are all working on the same project. We have 500 source files. We have all of our project documentation, our documents of design, like design decisions, our requirements. They're all up in Subversion, okay? I, as the project manager, because that's my right as professor, I get to be the project manager. I go through and I lock everything because I want to make a change. So I go to our Subversion project, I right click 350 W2021, and I right click, check out, and lock. What that means now is that none of you can make a change. Okay, you can all pull it down still and work locally, but you are at my mercy of when I unlock this project. Whereas in Git, you can all just keep pushing your commits as you go because you have the entire administrative end on your local computers. We're going to have to resolve merge conflicts later on if that's the case, but you're not stuck waiting for somebody to unlock files. All right, so that's where I'm going to leave you with for today. Any questions before I sign off? Yeah, I think there is something to your analogies there, though. I like that where we're going with that. Alrighty, well, if we are all good, I will see you all on Wednesday. And my guess is, so Wednesday we'll have, I don't want to keep you any longer, but I'll probably try to give you a little bit of project team time on Wednesday if I can. So anyway, I will see you all Wednesday. Let's get some tunes going. Have a great day, everybody. Happy Monday. Bye. You too.